Hello, this is your video for your review for Unit 9. So number 1, what is the slope of the tangent line? So that means derivative of this at theta equals pi. So we're going to need to get x, we're going to need to get y. So x is r cosine theta. And y is r times sine theta. And so our dy dx, we're going to do our derivative of y, dy d theta over dx d theta. This will make it better. Okay, that's a little bit, well, it's kind of washed out. I don't know. Do my best. All right, so it's going to be a product rule. So we're going to do the first times derivative of the second plus the second times derivative of the first. The 3 is a constant, so that's going to be gone. And it'll be -2 cosine. And we're going to do the exact same thing with our x. So first derivative of the second, which is negative sine, plus the second times derivative of the first, which is going to be the same thing again. All right, and then we are going to plug in pi. So we're going to do this derivative such that theta equals pi. So pi is on the left side of our unit circle. Sine of pi is going to be 0. So this first part is just 3. Cosine of pi is -1. Sine of pi again is 0. So this entire part is going to go to 0. This again will just be 3. This will be 0 though. So actually that whole part is going to be gone. And then cosine of pi is -1. So -1 times -2 will be +2. So our numerator is -3. Our denominator is -2. Negatives are going to cancel. So 3/2. And you do have to see that through all the way until the end because it's going to be a multiple choice question. All right, polar curve is given by this f of theta. The line tangent to the curve, so this means derivative at pi/6 is vertical. Vertical tangent line means that we want to look at dx d theta. So x is going to be r, which they don't actually give us. It's just some function of theta times cosine theta. So we're going to do our dx d theta, and we're going to set it equal to 0. Vertical tangent line means we want dx d theta equal to 0. I decided this is not making this any better. A little better. All right, so we're going to do our product first thing times derivative of the second plus second times derivative of the first, which is just going to be f prime of theta. We don't know what that is. We're going to set this equal to 0, and we're going to plug in pi/6. So this first part is just going to be f of pi/6. I don't know what that is. We have to just leave it. Sine of pi/6 is 1/2. So this will be -1/2. Cosine of pi/6 is square root of 3/2. And then this will just be f prime pi/6. Answer choices do look like that. All right, number 3, polar curve is given by r equals all of that. We want instantaneous rate of change. That means derivative. Now, what's nice about this one is it's r with respect to theta. So we don't need to find x and y. We can just do the derivative of this and then plug in 1 for theta. So it is going to be a quotient rule. So it's going to be the denominator times derivative of the numerator minus numerator times derivative of the denominator over denominator squared. And we're just going to plug in 1 for theta. So 1 minus 5 will be -4 times 6 will be -24. Plugging in 1 here would give us 6 times 3, which is 18. And then down here, we're going to get -4 squared, which will be +16. So let's see, that's going to be -42 over 16, and they're both going to divide by 2, so -21 over 8. So we did a quotient rule, and we plugged in 1. All right, let R be in the first quadrant, bounded by, all right, this is our graph, and theta equals k, so some number. What is the area in terms of k? So we're going to set up our area formula, 1/2 r squared d theta. We're in the first quadrant, so we're going to start at 0 and go to whatever this k number is, and then r is what goes in there. So if we square that, I'm just going to leave that parenthesis. It's going to be 9 theta squared d theta. And then we're going to do our antiderivatives, the 3 theta cubed, such that 0 to k. Right, and then we're going to do upper minus lower. So if we plug in k, that's just going to be 3/2 k cubed. And if we plug in 0, we just get 0. So it'll just be 3/2 k cubed. And it said in terms of k, so that is what that's going to be. All right, write an integral that gives the area enclosed by the smaller loop of this. All right, so let's set up our integral. 1/2 r squared d theta, so r is what's going to go in here. And it's multiple choice, so if you can even get this far, you're going to be able to narrow down your choices. Now, if we want the smaller loop, it's going to be something that goes, around and looks sort of like a heart, but with like an inner loop. It's going to be where the graph touches 0 and then goes through 0 again, without having to, laboriously go through, drawing an entire graph. I can just set this equal to 0 and find those values, and I know that's where my inner loop is going to be. So if I subtract over the 2, divide by 4, I'm going to get -1/2. And if you want to use that little cheat sheet that I gave you, you won't be able to on the AP exam, but where cosine is going to equal -1/2 is going to be in the second quadrant and the third quadrant. So that's going to be, not negative, 2 pi over 3 and 4 pi over 3. And so those are going to be our boundaries. But like I said, if you can't get that, if you can at least know it's 1/2 r squared d theta, you are going to be able to narrow down your choices and at least make an educated guess. All right, write an integral that gives the area enclosed 0 to pi over 3. So those are going to be our boundaries. And here's r. So it's 1/2 r squared d theta. And that 0 and pi over 3, like I said, are the boundaries. And then r goes in here. 5 minus cosine. So, that is the integral. In multiple choice, they're going to clean that up a little bit, though. 12 squared is 144, and then half of that is 72. So in your multiple choice, it's going to look like this. But that's the answer. You don't have to work that out or anything. It just said to write the integral. Right here, we're going to do a Riemann sum. Table gives values for r. We want to use a left sum with these 4 sub-intervals. The nice thing is all the sub-intervals are the same length. They're all 1/2, so that's convenient. We're going to do 1/2, 0 to 2, r squared d theta. So it is going to be 1/2, because we have a 1/2 there, and then 1/2 because that's the length of each sub-interval. And then we're going to do the values on the left, but they're going to be squared. All right. So 2 squared is 4, 6 squared is 36, 7 squared is 49, 3 squared is 9. And the only thing that's going to be different in multiple choices, they're going to multiply 1/2 times 1/2 and put a 4th, but your choices will look like that. So that's all you need to do there. They don't make you actually work it the whole way. So this one, we want a region of this polar graph and the x-axis from 0 to pi. So again, we're going to set it up. And actually, if I plug that in here and square it, the squared and the square root are going to just, undo each other. So it's actually going to just be 3 plus, 2 over pi theta. So essentially, we're going to do a fundamental theorem of calculus. We're going to do an antiderivative and then upper boundary minus lower boundary. So it is going to be 3 theta plus, all right, this would be theta squared, and then we would divide by 2. So the 2's are going to cancel. And again, we're trying to come up with a function that if we did the derivative of this, we would get 2 over pi theta. So you can check that. Like if you brought this 2 down, it would be 2 over pi. Drop this to a 1, it would just be theta. And then we're going to do upper boundary minus lower boundary. So this is going to be, well, let me stick a 1/2 out front. 3 theta, 3 pi, plugging in pi for theta, plus pi squared, and then divided by pi would just be another pi. And then if you plug in 0, actually the whole thing is going to just go to 0. So let's see, this would be 4 pi, and then half of that would be 2 pi. All right, write an integral. So we're going to not actually find the whole answer, but just write the integral that gives the area of the region inside both of these. And then they give you 2 equations. So we want this part right here. We're going to go from 0 to pi for just this one. So we're going to have 1/2 0 to pi r squared d theta, and I'll come back to that in a second, plus, and then we want to go from pi to 2 pi of this one. So 1/2 integral pi to 2 pi r squared d theta. So we just need to figure out which graph is which. So I would start by trying to plug in 0. And there's nothing labeled on these axes. In fact, let me get rid of the shading that I did here so I can write more stuff on this. So that makes it extra difficult that we don't even have tick marks on our graph. But let's see what we can do. All right, sine of 0 is 0, plus 4 is 4. So this must be 4 right here. Then let's do pi over 2. Sine of pi over 2 is 1, plus 4 is 5. And sine of pi over 2 is 1. So this would be 3 plus 4, which is 7, which would be up here. So this must be 5, and this must be 7. So this graph, the one that I want to go in here, has got to be this first one. And then this one that hits 7 up here has got to be the second one. And that is what your answer choices are going to look like. They all look something like that. Now, you'll be able to narrow it down by ones that don't have halves in there or ones that don't have the squared in there. And that's why setting it up ahead of time, like setting it up blank, is so important. And then you can narrow down your answer choices. So this one I put on here for 2 reasons. Number 1, it's good to have review questions. And number 2, if polar is not your thing, then you can get a lot of points from this question. So we're going to use this table, and this is all about derivative rules. So we're given this function h of x equals f of g. We want to do the derivative of h and then plug in 5. So this is your chain rule. We're going to do derivative of the outside, leave the inside alone, chain on derivative of the inside. And then we're just going to use our table to find all those values. G of 5 is going to be 8. And then we want to do f prime of 8. So that is going to be 3. And then g prime of 5 is negative 3. All right, next one, we are given k prime equals all of that. And then we're asked about concavity. So concavity involves the second derivative. So if we're given the first derivative, we're going to have to get the second derivative. We're going to plug in 1 and see what we get. So this is going to be both a chain rule and a product rule. So it's going to be the first thing times derivative of the second plus the second times derivative of the first. The 3 is going to come down. It's going to drop to a 2, and then we chain on f prime. So now we're going to plug in 1. We're going to use our table. F of 1 is 9, and then that's cubed. And then g prime of 1 is 3. G of 1 is 4. And then we've got this 3 that's there. F of 1 is 9, and that is squared. And then F prime of 1 is 2. Now this is free response, and I am not going to go and figure out what all of that is. All we need to know is whether this is positive or negative, and I know that it is going to be positive. So we are asked about concavity. We're going to say K, all your sentences should start K of X is or K of X has, whatever function you're talking about. So K of X is concave up at X equals 1 because second derivative of 1 is positive. So we find the second derivative, plug in 1, and then give your explanation. Let m be this function. We've got an integral in there. Find m of 8. So we're going to plug in 8. So this is your fundamental theorem of calculus here. We have an integral of a derivative. If you do an antiderivative of a derivative, it takes you right back to the original function. So it's just going to be g of x such that 0 to 8. And I don't need to simplify this because it is free response. So that part, just leave it alone. 64 times 4, it's not worth it to figure it out. If you mess it up, it's going to be wrong. It's a timed test, et cetera, et cetera. Upper boundary minus lower boundary. The most common mistake I get on this question is people put 0 for this. G of 0 is probably not 0. We have to get it from the table. We're going to do G of 8 minus G of 0. So G of 8 is 7, and G of 0 is negative 2. So please don't just assume that that's 0. You have to get it from the table. And then we're going to use that same function, increasing, decreasing, or neither at 8. So we're going to get the derivative. We're going to plug in 8. And then we're going to write our explanation whether the graph is increasing or decreasing. It'll be dependent on whether this derivative is positive or negative. So our derivative of 4x squared is going to be 8x. And then your integral of a derivative, they're going to cancel out. So it's going to just be g prime of x. And then we're going to plug in whatever it is, 8. So that'll be 64 plus g prime of 8, which we're going to get from the table. G prime of 8 is 2. And this is positive. So we're going to say m of x is increasing at x equals 8 because, oops, the m not n, m prime of 8 is positive. Negative would mean decrease. All right, so these ones are our calculator problems. And so I'm going to have to keep going back and forth between the calculator and my paper. I'm going to go ahead and go to the calculator because you all have this on paper. Also, you can see this off to the bottom of the screen here. So this one is asking for the second derivative at theta equals 2. So what I would do for this is I would write a function that is dy d theta over dx d theta, because that's going to be your first derivative. So dy d theta is, and I'm using x instead of theta just because it's a little easier. And then I want to divide that by dx d theta, which is, and again, I'm using x, plus x. Cosine x. All right, so this is, I realize it says f of x, but this is our first derivative. So if we want to do our second derivative, I'm going to do the derivative of that specifically at 2, but then you have to divide by dx d theta again. So I want to divide by this, I want to divide by this part again, but at 2. So I'm going to replace all of these x's with 2. And then that's our answer. I made up this question, and so that is why it came out to negative 13,000 and something. The one on your test will not come out so weird. It is negative 13,140.611. All right. What is the area bounded by that R graph from 0 to pi? They gave us everything we need. We literally just need to set it up. It's going to be 1/2 0 to pi r squared d theta. And r is 2 theta minus sine theta. And we are literally just going to put that in the calculator. So they gave us all of the information that we need, and we just need to plug it in. All right, 15.173 is our answer. So not much to that one. You just know the formula to get an area. They gave us everything we need. You just plug it in. All right, what is the area of the inner loop of this graph? So we did one similar to this earlier. To get the boundaries for your inner loop, you're going to take this and set it equal to 0. It's going to be 1/2 r squared d theta. But to get those boundaries, again, we're going to take this and set it equal to 0. So if you subtract over the 3, that's -3. Divide by -6, that would be +1/2. And that is going to give you, again, you can look at your cheat sheet if you want. It's going to be pi/6 and 11 pi/6. And then we're going to just put that in the calculator. Oh, did I mess something up? That's a way bigger number than I thought it was going to be. What did I say? Oh, no. 11 pi/6 would be -1/2. I am so sorry. It should be 5 pi/6. Second quadrant. I was thinking cosine. For sine, the second quadrant is where we're going to get +1/2. I am so sorry. That came out to a way bigger number than I was expecting. It should be 5 pi/6. I am so sorry. There we go. I knew it was going to be a way smaller number. 4.891. All right, using these two polar graphs, we want the area that includes the circle, but not the rose graph. So we're going to do the circle minus the rose graph. So what's nice about this, I can't get that to say. What's nice about this being calculator is you can actually plug it in and take a look visually at what the graph is going to look like. So we're going to put in r equals 4. That's going to be a circle with a radius of 4. And then we're going to put in r equals 4 sine 2 theta. Oops. So we want the part that includes the circle, but not the rose graph. So we want this portion right here, this portion right here, this portion right here, etc. So we're going to do the circle minus the rose graph. So let's think about what the area of a circle is. Area of a circle is pi r squared. So we're going to do pi times 4 squared. That's the circle minus, and I'm going to leave a little gap here, the area of the rose graph. which is going to be 1/2 r squared d theta. So this 4 sine of 2 theta goes right there. We need to figure out our boundaries. So I'm going to go back to the graph. And so I would do just this first kind of petal or leaf of the graph, which would be from 0 to pi over 2. If you plug in 0 or pi over 2 to this, you're going to get 0. So that's where you're hitting the pole. So just this one petal is from 0 to pi over 2. So we're going to go from 0 to pi over 2, but I left a little gap. There are 4 petals. Oops. So I need to subtract out all 4 of them. And then I'm going to put this in the calculator. All right, so it's going to be pi times, oh, well, that's just going to be 16 pi minus 4 times 1/2 would be 2 integral 0 to pi over 2, and then r squared all right, 25.132. So we're doing the circle, which is pi r squared. That would be 4 squared times pi, so 16 pi, minus all 4 petals of that rose graph, so 25.132. Right, using these 2 graphs, we want the area inside of this graph and outside of r equals 2. So again, the nice thing about this being calculator is we can type them in and see what it looks like. So we have r equals 2. That's going to be a circle. What is that? 6 sine theta. So we want the area that is, what was it, inside of this black graph, but not inside the purple graph. So we want to go from here, this intersection, to here, but we want to do the black graph minus the purple graph. We want this area. I can't make it shaded in, but where my cursor is, like trying to color in, we want that area. Now, the thing is, we need those intersections. So what I'm going to do is I am going to, I'm going to use x instead of theta. I'm going to type in each of these. Oops, and get the intersections. And so we're going from here to here. We want the very first intersection to the next intersection. I'm going to export those points. Those are going to be our boundaries. We're going to go from there to there. And we want to do the area. So 1/2 integral from here. Let me copy and paste to here. And we wanted to do what was the black graph minus the purple graph. We wanted the area inside, I can show it again once I get out of this equation, but we wanted the area inside that 6 sine theta. I'm sorry to put a parenthesis. Well, I might need another one. Minus what the circle was. And so that is going to be our area. So 22.890. So let me show you again. I'm going to write that down on my paper, 22.890. But I just want to show you again because I don't know if it'll work with all of this in here. So let me try r equals 2. Oh, there it's doing it. All right, r equals 6 sine theta. So again, I typed in 2 different functions to get these boundaries. I don't know what they are, and they're not on the unit circle, so that's why they're weird decimals. So from whatever this is to whatever this is, and it recolored the graphs. So this time it's the blue one minus the red one. We want this area right here. So I didn't really have any kind of work for that. I did it all in the calculator. And then we have our last free response. Polar curve R is given by this monstrosity. Find the area bounded by the x-axis and R from 0 to pi. All right, they gave us everything we need. We're just going to set it up and type it in the calculator. So 1/2 0 to pi r squared d theta. Make sure you write on your paper what it is that you're typing into the calculator. I didn't leave enough room. They don't like to have what's called a bald answer. So they want you to show what it is that you're typing in. So unless it's multiple choice, which in that case you're choosing an answer choice, make sure that you write down on the paper what it is that you're typing into the calculator. So we're going 0 to pi. We want that r function 2 minus, oh, I guess it's not a function, but equation. 2 minus sine 4 theta, cosine 4 theta squared d theta. All right, 6.479. I like that question. It's simple. They gave you everything that you need. All you have to do is set it up and put it in the calculator. All right, this is average distance. It's an average value from the pole. R is the distance from the pole. R is how far away from the pole you are. So it's just R. Average distance is just R. Average means that we need to put that fraction in front of the integral. So it's going to be 1 over pi over 2 minus 0. It'll just be pi over 2. And then integral 0 to pi over 2 of R. And we're going to put that in the calculator. All right, so 1 over, I didn't write the minus 0, pi over 2 minus 0, integral 0 to pi over 2, and then I'm going to put this R equation. I'm not sure if it needs parentheses here or not, but I'm going to put one. This does not require, oh, it's just 2. Cool. This does not require a squared here because we're not finding an area. We are finding the average value of R, the distance from the pole, from 0 to pi over 2. So you do not need a squared there. And that just came out to 2, that kind of geeks me out. All right, letter C. Find the rate of change of y with respect to theta at the point 3 pi over 8. Then, okay, you know what? Let me not deal with the then right now. We're going to do one thing at a time. So we want dy d theta at 3 pi over 8. To find y for this r equation, and then we're going to have to do the derivative of that at a point. So I'm going to come over here, get rid of this. I'm going to call it x again, just because that's easier to type. Y is going to be r sine theta. So r is 2 minus sine of 4 theta, but I'm going to put x, cosine 4x. So again, y, which is what we're looking for, is r sine theta. And what it's asking us for is the derivative of y at 3 pi over 8. I don't love that question. That was just a lot of button pushing. I didn't really do any math. I wrote an equation here for r sine theta. I know that that's y, it's r sine theta. And then I did the take two. I did the derivative at 3 pi over 8. And I got an answer, but it's kind of like, what do we really do there? Anyway, 4.460. So our y derivative at 3 pi over 8 is 4.460. So you're writing what you put in the calculator and then giving an answer. It says then find the slope of the tangent. So that's dy dx. So we need to look at both y and x at 3 pi over 8. So it's going to be dy dx at 3 pi over 8. But again, it's all going to just happen in the calculator. So I'm going to make another equation for x. I'm going to copy and paste here. So x is r cosine theta. So I'm going to just change that to cosine. And we want derivative of y over derivative of x at 3 pi over 8. Again, I don't love that question. It was just a bunch of hitting buttons. But this is y, r sine theta, and this is x, r cosine theta. And I did dy d theta over dx d theta at 3 pi over 8. And that's our answer, negative 14.071. So just make sure you label them. We didn't really do any written work for this. We typed it all in the calculator. But this is, you could also write dy d theta such that theta equals 3 pi over 8. I just wrote y prime 3 pi over 8. And then this is the whole thing with y and x. Yeah, again, don't love that question. This is particle motion. Particle is moving along the curve r so that d theta dt equals 3.1 radians per second. We want dr dt at 2 pi over 7, and then we're going to have to do a little interpretation of what's going on. So we want dr dt, and that is going to be dr d theta times d theta dt. You can think of it like the d theta is canceling out. That gives you dr dt, but we're going to get the derivative of r with respect to theta at this value. We're going to use the calculator and then multiply it by this 3.1 radians per second. So again, this is all going to happen in the calculator, but I'm going to label it. What is it? 2 pi over 7. So we're going to get the derivative of r at 2 pi over 7 and then multiply it by 3.1. So let me get rid of this. Let me get rid of this. So r is just this part. I just got rid of the sine x there. So I want this derivative at 2 pi over 7. And then I want to multiply it by 3.1. So I got negative 7.731. And then it asks us to interpret that. So since that's negative, well, here, let me start at the beginning. R is the distance from the origin. So if we find the rate of change of R, if that's positive, your particle is moving away from the origin. If it's negative, your particle is moving towards the origin. It's kind of like going away from home and then coming back towards home. So since this is negative, our particle is moving toward the origin. Or you can call it the pole, since we're doing polar, at theta equals 2 pi over 7. And it is moving at 7.731 units, because we don't have feet or meters or whatever, per second. It is per second because they said seconds right there. But I don't know how far away from the origin it is. They didn't give us, miles or any distance unit like that. But towards the origin, because this is negative.